Today I want to talk about collations, which is, I've been working on this for a long time. I think there's some interesting new developments in Postgres that are worthwhile to point out. And there's also a couple of problems that we have learned about recently again, and that I think are important for all users. So what's a collation? What does it even mean? Why do we do it? So we know, of course, about sorting in database systems. That's important topic in computer science in general, and also in Postgres. There's many different interesting talks and blog posts and things like that about that. Don't want to talk about that today at all. What I want to talk about today is how do we even decide what order things should be in, right? So for some data types, it's kind of obvious. For numbers, you just use the order of the numbers, and for other data types like dates and timestamps, there's just a natural order to things. But for text, it becomes more complicated, right? There's obviously also sort of an ABC kind of what you want to start with, but of course there's issues with different languages and sometimes different opinions within the same language, and also what do you do if you have multiple languages, and also some other kinds of options, what you do with special characters and things like that. And that's interesting because in almost all applications you somehow present text to the user at the end, right? Because you have a lot of numbers usually in your databases, IDs and things like that, but at the end of the day you want to show like a list of names or a list of products in a sort of useful and sensible arrangement. So it is quite important to get this right. So here are some sort of things to motivate, like how would you do some of these things, and I'll try to resolve some of these. All right, so don't have to do everything here and go through in detail, but obviously there's some accents and special characters, uppercase, lowercase, spaces. Some of these are like a German example and then a French example, like how do you do these kind of things, right? So before we dive into sort of the details of that, let's talk a little bit about some, Unicode and character sets and things like that. So of course there's different character sets. This is not exactly relevant to this, but it comes up in the same context. In the beginning we had ASCII, it just obviously didn't satisfy requirements for multiple languages. When you sort ASCII, you usually just use the byte values, and then you get the letters in the order that the bytes happen to be in. That doesn't really work in practice because you have all the uppercase letters and then all the lowercase letters. So you have A, Z, and then A, Z. So that doesn't work, right? So, and then we had at least in Europe, the 8-bit character sets, ISO 8859, also known as Latin 1 and Latin 9 and things like that. So, and now we have Unicode, which supposedly encompasses all these character sets. So in what I'm going to talk about now, you're going to use Unicode, because that's what everybody really uses nowadays, and how all these things are defined. If you use other character sets, it's mostly just it takes what Unicode does and then just sort of narrows it down for that particular character set, but the implementation for all these different character sets is the same, right? So, but do use Unicode if you can. So Unicode itself, the standard, is mostly about just characters. It has thousands of characters, and it kind of defines and how to display them and what properties they have and stuff like that. That's Unicode. But outside of the core Unicode standard, there's also a number of additional standards documents, and they're called Unicode Technical Standard. This is what the UTS stands for. And there's also sometimes called Unicode Technical Report, UTR. It's kind of used interchangeably, but I checked, it's now called UTS. And the one that's interesting for us is UTS number 10, which is called the Unicode Collation algorithm. So if you just Google for that, you get that document. They're all free to download from Unicode. And that defines how this is supposed to work in very much detail. And I am just basically going to summarize that, right? So, and then there's another standard, an ISO standard, 14651, which is pretty much the same as that one, just kind of republished through ISO. So it's kind of more official if you kind of follow the ISO standards. And then there's also national standards in, I presume, most countries that basically also copy that and then adjust it for their local requirements. So if you're building a software system and you want to follow sort of the industry best practices, look what the national standard in your country is, or for your language, as the case may be, and it usually refers back to these things. So that, this is basically what everybody is using, is what I'm saying, right? Okay, so now we've seen here on all these examples, it's not just like you can't just take the letters and put them in some order. That doesn't help you with uppercase, lowercase, special characters, and this kind of thing. So there's more going on. So how does that work? So let's look at an example. My clicker works. Here you go. So Unicode collation algorithm. We have two strings, A, B, C, D, F. We know what the result should be, right? So how does it actually work? So we don't use just one number for each letter. There's, at least in the default setting, there's 3. These are called weights. So there's 1, 2, 3. This is kind of the text file that you can download from Unicode that defines all these numbers. That I literally just copied that from there. It kind of looks like that. So there's 3 numbers for each letter, right? There's a small letter A, B, C, D, E, F, and for each letter, there's 3 numbers defined here. This is just the Unicode code point for these letters. So this is the actual data that we're looking at. So primary weight, secondary weight, tertiary weight. So 3 levels. And you can see the second and third one are all the same in this case. That's just because they're all small lowercase Latin letters, so it's not that interesting. But if you then want to compare these, what you do is you take the first weights and append them. So here we're going to do the A goes here, the B goes here, the C goes here. And for the other string, this one goes down here, right? These are the three numbers in each case. Then you put a 0 as a division separator. And then you use the secondary weights, all the same here. So you put 20, 20, 20, another separator, and then the third weight. Okay, that's called the sort key. And that's then what you actually compare. Then you pass that to memcompare or whatever the case may be, right? So that's how that actually works. It looks pretty excessively complicated right now, but this is actually how it's implemented, and then we'll see how this actually works out in some extra cases. So now in practice, so this is how it's actually implemented, like in glibc, for example. Of course, you don't actually have to compute the full sort key because this is quite expensive. If you look at it, these are 2 bytes times 3, so 6 bytes per character. So this would be a lot of memory. In practice, you can do this incrementally and just see how far you have to go. Or you can also compress this if you have to store it. So there's a couple of options to do this better in practice, and also the UTS number 10 actually gives some hints on how this could be done in a more optimal way. But this is the theory, okay? So how does this work if there's different lengths? So this just works just fine. So because here you have the 0 as the separator, then you see the 0 is less than this letter. So the shorter string is always less than the longer string. That's what you would expect, right? So just to show that this actually works. So here now is some interesting stuff with accents, uppercase, lowercase. How does that work now? So let's look at these weight definitions again. So the first level is the same as we had before, so that doesn't change. Again, this is just from the standards documents, right? But you can see, for example, here on the third weight, there's different numbers now. So you can see for the lowercase letters, they have a 2. For the uppercase letters, they have an 8. Uppercase has 8, lowercase is 2. Why is it 2 and 8? Doesn't matter, right? It just matters if one is bigger, one is smaller. And then for the accents, this is actually spread into 2 collation elements. Why, I don't know, but here they have the accent is somehow encoded in the secondary weight here, right? So we have this one accent here, and then this one is here. So again, the details and the numbers don't matter. It just matters that they come out in the right order at the end. But what is happening here, and this is kind of the takeaway, is that the first pass is just a letter, the base letter, so to speak. The second pass is the accent. And then the third pass, you compare the uppercase versus lowercase. This is how it works. So if you're ever confused by how these things come out in what order, it's always the base letter first, then it compares the accents. And the accents are put in some order. Who knows why, right? That's just probably more or less arbitrary. Why is the acute accent is less than the diuresis accent? I don't know why. And then you compare uppercase, lowercase at the very end. So again, you just use, in the implementation, you just append these things. And if you have a 0 here in the primary, you just omit it. So this is actually the sort key. You can see this is the base letters. Here you have the accents, and here you have uppercase, lowercase, and then you just compare that, okay? So in this case, the result would be that this is less than that because the A is less than the D. Okay, so basic principle clear. You don't have to do this by hand because the software does it for you, obviously. So you can just, but just so you have an understanding what's going on under the, so. Now, this is our French visitors here? No. So this is an interesting special case. You can think about how this would, why this is. So these are 4 words in French. They're all real words. And this is kind of a classic case of this particular feature that I'm going to explain. So you can kind of find these examples online. So if you do the default collation, and we'll come to this stuff later, but this is basically the default. You get this order, right? Because the base letters are all the same, C-O-T-E, and then you compare, this one doesn't have an accent, this one doesn't have an accent, this one has one, this one has one. So this is how that is decided, right? And then at the end you say, this one does not have an accent, this one doesn't have one. This one has one, so this is bigger. So this is what you would expect. Now if you use this locale, you get this one. And how is that possible? So the answer here is that it actually compares from the end of the word to the front backwards. Yeah. So this is why it considers the last letter first, and then it only so it checks the E first, the accent on the E, and then the O. So this is how you get this order from the back to the front. So this is kind of crazy. So this is a special case in the Unicode collation algorithm that addresses this particular requirement that was traditionally used in French. Now, it seems that even the French thought this was a little bit too silly, and the latest locales that you get for French in France don't actually do this anymore. But the French in Canada locale apparently has not updated its local standard yet. So if you use this French in Canada locale, you still get this old sort order. So this is a very bizarre special case, but it uses the same algorithm ultimately, right? It uses the same idea that we had here, it just flips this one backwards. Right? So this is the kind of stuff you can do with this. All right. So now comes the one where people usually complain, and we get every 6 months a bug report to Postgres saying like, here's some stuff I sorted. I think this is wrong. I think this is the wrong order. I expected this to be here. Why is this here, right? So this usually comes down to the special characters business here. Special characters, like what's the special character? Well, this is defined in these tables, but usually it's things like space, period, hyphens, slash, plus, all those things. And there's, of course, hundreds and thousands in Unicode. But these are obviously very common, so this affects everybody. And there are, the trick really is that there's multiple official ways to do it. And some of these might be, you might expect a different one. But they're all legitimate. So that's what causes the confusion. So I'm going to show these different versions. The easiest one is this. So here's the space. So these letters we already had. These are just standard small letters. The space, if you can see, this has a star here. Again, the star doesn't mean anything, but it's just the way that this data file is provided. So you know the star means this is a special one. This has special behavior. Yeah, it's cut off a little bit at the bottom, so we'll have to see if I can show this. Let's see if I can just scroll down here. Yeah. It doesn't scroll. I have no scrolling here. I don't know why my scroll bar is gone. Anyway, we'll figure it out. The easiest is that you just use the weight as is, you just do what we said, and then you get this result, right? That you have the word with the space before this other word. So you basically have this one first, then this one, and then that one. That's because the space comes before the A and then the L. This is kind of sort of almost like an ASCII kind of sort, right? So you have first the space, then the A, then the L. So okay, you can do that. This is called non-ignorable. We'll explain that in a moment. This is usually, I mean, this doesn't, you can do that, but that's usually not what you want. You want something that kind of makes these two words closer to each other, right? So that's option one. Option two, and this is where it gets fancy, is that it's called shifted. That means you shift the weight. We had this one here, right? You shift it and you add a fourth option, a fourth weight. So you shift everything back for the space, and then you add the FFFF for all the other letters. Okay, so you add a fourth pass, basically. So you first compare the letters and the accents and the capitalization as we had before, and then you use the special characters. And then you get this order. So you get first death, then you have deluge with the space, and then you get this one. So that is probably better. And then there's this is kind of what you get now if you use basically just a Linux system with glibc. This is what you see. This is what people usually complain about, because they usually want this, but they get that. And we tell them, well, this is actually the correct one. So then you have the option shift trim, which is the same one, except you remove the FFFFs at the end of the sort key, and then you get the order. Let's put it here. You get this one first, and then you get this one, and then you get that one. So in this order, right? So you get 3 different ways you can sort it, and you get 3 different results. And it's basically up to either you, the application developer, or the DBA, or the implementer of glibc, or whoever decides which option of these is the correct one, right? And there's a couple ways to choose. So these are the four ways you can do it, and they have these names. So the first one is you just treat it as a normal letter, which we saw doesn't have a good result because you have the words with the space and without the space, and an unrelated word in between. There's blanked, where you just ignore it altogether. That's actually not implemented, but it's in the standard. And then you have these two, which is basically these 2 variants here, right? That sort of treat the special characters as a fourth pass. So which one you get depends on what version of which software you have. And that this is also going to cause some confusion as people update. So in the old glibc, which is included in these operating systems amongst it, you get the shift trimmed version, which is the traditional kind of POSIX Unix behavior. In the new glibc, starting in version 2.28, which was released last year, 2018. So this is coming up in sort of the next wave of operating systems that are including that. So Fedora 29, Red Hat 8, which was released last week. And then the next Debian is also going to include that. So there's going to be a change as people update to these new versions of their operating systems. And this is probably going to cause quite a bit of confusion in the Postgres community, because all of a sudden all the sort order is going to be different after people update in this particular way, right? This is the technical detail. Yes?
Would that cause problems with all the existing indexes?
Yes, it will cause a lot of problems with all the existing indexes. I'll get to that, yes. So in ICU, you have 2 options. You can do the non-ignorable, which was the first one as a default, and then you have an option that you can pick shifted. So, which gets us to the collation provider. So I explained how the algorithm works. And so, but this is not implemented in Postgres. Postgres doesn't do that. Postgres uses just some library and says, here are 2 strings, which one is bigger? And there are 2 libraries that Postgres can use, and those are those 2. And the default one, or the one that's always been in Postgres, is of course the C library that's just in the operating system. I keep mentioning glibc. Of course, if you use FreeBSD, you use whatever they have. If you use Windows, it's whatever. It's in the operating system, right? And then as a second option was added in Postgres 10, you can use ICU. And ICU is International Components for Unicode. That's a separate library that adds all kinds of Unicode functionality. Obviously the sorting, but it has things like line breaks and formatting and dates and times and paper sizes and all that kind of stuff. So it goes much beyond what we're talking about here, right? But it's very good, and they really care about getting this right for all the different languages and cultures and so on. So how to use that? If you create a collation, you can pick what provider you want to use. So you can use both at the same time. You just say like, for this collation, I want to use libc, and then you give it a locale name from your operating system, okay? And then you can use it in your table or in your domains or expressions and so on. Or if you want to use ICU, then you just write ICU, and then the syntax for the locales is a little bit different. Yeah, so this is what you might know from your operating system locales. In ICU, it's more flexible and has different features and options. So you just have to write language, or you can do language country, as you might know, as you might be used to. But it's usually enough to write this as far as I know, for Italian, there's IT of course, there's ITCH, as you probably know. In German, there's actually some different options for, like, Germany is different from German Austria. So depending on what language you have, different countries might have different preferences within that language, but for most languages, just the language is enough. And there's actually an online, it's an online interface. If you go to the ICU website, there's sort of a locale browser where you can just browse around and what is actually in those locales and what do they do. It's fairly complicated, but the information is somewhere out there. So this is if you have a collation, like you define a collation, you put it on a column. There's also a database-wide collation, which is probably what most of you are using, unless you specifically override it. That is always using libc, and that's something we want to change eventually for reasons I'll get to in a moment. But so when you create a database, you pick a locale, and that's the locale that's always used for everything unless you specifically create a collation. So if you wanted to use ICU, then you have to do it sort of per table, which is not super convenient. So again, we want to change that, but right now that's the way it is. So the nice thing about ICU is, amongst many other things, it has options to customize the sort order. So for example, by default, you have lowercase letters before uppercase letters, as we saw earlier how that works. So you normally get this sort order. If you want to do it the other way around, because of your application requirements or preferences, there's an option for that. The syntax is, there's two syntaxes in ICU. This is kind of the new one, this is the old one. Old one is probably easier to read, but the new one is, has more flexible features. It doesn't matter right now. So you just give it this option, okay, I want case first upper, and then you get this result. So super useful, it's just there, you just pick it. You don't have to do any sort of lower uppercase stuff yourself or weirdly do rearrangements that people sometimes do. So it's all there. So here's an example from a typical case from Germany, or German rather. So there's something called like a standard sort order in German, and then there's a phone book sort order, which, if you're too young to know what a phone book is, it's like when you print out the internet and then throw it away. That's it's a phone book. And for historical reasons or whatever, there's two different sort orders. One is mostly used for names, and one is used for anything else. And you can just pick that here, right? So use whichever your application requires. This one is super useful and probably widely unknown, but if you have sort of product numbers and things like that have letters and numbers, but you want to sort them so that the numbers are actually sorted like numbers, while ignoring the letters, right? It's kind of very common with like, you know, invoice numbers, product numbers, things like that. There are sort of hacks and stuff around that, but it's actually all built in. You just have to use it, right? So you pick this additional option here, numeric sort, and then you get this, right? So you guys all understand what's going on here, right? So instead of going character by character, it actually sort of looks at sequence of digits and then actually converts them to a real number and compares. So again, this is just there, you just have to use it. And this actually, because it's Unicode, this also works for things that are not sort of what they call the Arabic numerals, I guess, right? That's how we call them. Like these kind of numbers, but there's also other numbers like in India, for example, or some other writing systems have other digits. But because it's Unicode, Unicode knows what is a digit, and then it would also work for that, for example. Allegedly, I've not experienced enough to actually try that out, but it should. And then there's also this is of course very important. There's a special option to sort emojis, and there's actually also a standard for that. We laugh here a little bit, but the reason for this is that when emojis were added to Unicode, they just kind of added them the way they came, right? There's a new emoji invented every week. They just kind of append them. But then once they're in there, they don't want to change the sort order because they want to keep everything stable, right? So they don't want to have every new Unicode release reorder characters because that would cause, you know, upsetness from application developers. So there's a separate standard that has sort of a very elaborate explanation of how this emoji sort works, and you can see this. You know, this is just some things I generated automatically. There's in some fairly random order essentially, right? But here you can see there's a system behind it. There's first all the faces and then all the cats. And then within the groups, there's actually the happy ones first and then the sad ones last. So there's really a system to that, okay? So now again, we kind of laugh and haha, this is, you know, silly. But of course, when you have like an application where, you know, you have like maybe an emoji picker that, you know, in chat applications and things like that, you usually have that. It makes sense to have an order to that, right? So you can find things easily, right? So this is actually useful. And actually just as I was traveling here yesterday, I read in a tweet somewhere that someone actually migrated away from MySQL to Postgres because Postgres has better emoji support, right? And so yeah, people use this, right? So it does matter. Okay, so case-insensitive sort. This is something that obviously many people want to do, and there's workarounds for that. This is usually what you do, right? And of course in Postgres you can index that also. Expression index, no problem, works fine. There's also an extension in Postgres, contrib extension, so it's shipped with Postgres. You can use CI text as the data type, and then it's automatic. Basically what CI text does is this internally. So before it compares, it lowercases everything. So that essentially everybody does that, it works, but because Unicode is Unicode, there's some special cases where it doesn't work. And so now, see, is anybody here from Greece? No, okay, so this is again sort of one of the typical sort of standard examples of Unicode special cases essentially. So this is Odysseus, the Greek character, right? So if you've paid attention in math, maybe you can see these Greek letters. This is O, D, this is Epsilon, sigma, sigma, and so on. So but the interesting thing here is that this sigma and this sigma is different from this one at the end, right? And this is this particular feature of the Greek alphabet, that the sigma at the end is different from the sigma in the middle. So if you were to do a case-insensitive search on this, maybe you enter this as your search term from your interface. So this is the uppercase sigma here. You probably recognize that from math class. If you lowercase this letter, it has to decide which one of those it picks, and it will by default pick this one. So if you do this, it will not match that. Okay. And this is a sort of well-known special case in sort of amongst European languages, but also in languages further away. There's more things like that where there's no one-to-one mapping between lowercase and uppercase letters, okay? Sometimes one letter maps to multiple letters and things like that. So this will somehow break. So that's why we've been working on a correct, correct solution, which is common in Postgres 12. It has a very complicated name, which will ensure that nobody will find it, but we'll make sure we'll put it in the release notes. So this is ICU only right now. So the way you would do this in ICU, knowing what you know now, the way the sorting works, if you want to do a case-insensitive search, you just omit the third level of weights, right? You just compare the first and second weight, ignore the third level, and then the case does not come into account at all. So in the ICU syntax, you can say whatever, something level 2. So you just want to do a 2-level comparison, which is basically code for case insensitive. So you can define it like this. If you want to ignore accents is the second weight. So you just say I want to do a comparison of only the first and the third weight. So it's a little bit trickier because you basically say I want to, again, this syntax is super complicated, but you can look this up in the documentation for details. You say I want to do a comparison only with the first level, but then I want to take the third level and make it the second level. That's basically what that says, okay? So, and in sort of translation to us, it means like I want to ignore accents, but I want to do case sensitive, right? Or you can do both, whichever you want.
How?
Huh?
How you can?
How do you do both?
Both level 1 and level 2 and level 3.
You want to do only level 2 and 3 comparison? That doesn't.
Just for an example.
I don't think you can do only level 2 and 3 because then you compare only the accents but not the letters. I don't think that would have a practical.
Ignore both.
Ignore both. Well, if you want to ignore both, you just write KS level 1 and ignore the rest. Right? It's basically only this part because this part at the end basically means to move the third level to the second level.
And in the first case, you also resolve the Greek case because you ignore.
Yes, because we just ignore it, right? So it doesn't. We don't compare the lowercase to the lowercase. We just don't look at it at all, right? So that's how that is fixed. Now in Postgres, if you do this in Postgres up to 11, it will not work because the way Postgres works is if two strings compare equal, it has a tiebreaker and it compares the bytes. That's how Postgres works. And this is called a deterministic collation. What you want to do is basically say, well, don't do that basically, right? You want to say, if these two are equal, then I'm just going to consider them as equal and I don't care if the bits are different. This is kind of the more correct behavior, but it causes some sort of performance overhead, so to speak, because then the problem with that is then that hashing doesn't work anymore. Because hashing requires if they're equal, they should have the same hash value. But if they actually have different bits and bytes, then the hash value would be different. So in order to fix that, hashing actually doesn't hash the string, but it hashes the sort key that we saw earlier, because the sort keys are the same. But then the sort key, of course, has to then be computed before hashing, so there's some overhead. We haven't measured it. It shouldn't be huge, but that's why this is not the default. Another problem is if you do this, some stuff doesn't work, like regular expressions, for example, don't work, because with this, it's not even clear what a letter is anymore, or what a character is, because it compares the whole string. And so there's no way you can actually do pattern matching over the string in sort of a case-insensitive way, because it's not necessarily guaranteed that one letter corresponds to another letter in the pattern. So this is very sort of complicated detailed cases, but if you do this and you say I want a non-deterministic collation, that's why this extra clause here I should mention, then it's not going to let you do like or regular expressions on that collation. Then you have to set a different collation. Okay. Maybe there's a solution for that, but it's not clear what the behavior even should be. So this is Postgres 12. Postgres 12 obviously is coming out this year, so this is not actually something that's in production yet, but if you're interested in that, we obviously can play with betas or then later this year. So this is then your question, and I think we'll just do a couple minutes extra. I got the 5-minute signal here, but we'll just, I think I explained earlier really quickly, you will notice that this is actually the change from shift trim to shift, because the characters here go in different orders, right? So this one is now up here, space is now down here, and so on. So this is basically the change from shift trim to shift. Why did they decide to do this now? I don't know. But it makes sense, because the UCA basically says that shifted is the preferred behavior. So now this is the big one right now, but glibc has actually changed orders all the time over the years, because mistakes were fixed or the languages actually have changed. In many languages, like sort of there were old behaviors, and then somehow the Language Academy decided we're going to fix, change, improve, modernize this now, and so then things change over the years. So this happens all the time. It's just usually small problems. People don't notice it. But we're expecting now, later this year, next year, over the next year or so, when people upgrade, it's going to break for everybody, basically, unfortunately, okay? So, and to make this, glibc collations don't have a version, right? In the ICU, they give you a version and say, okay, there's a problem because the version changed. glibc doesn't have a version, so there's no way to detect this, basically, other than by paying attention to when you do your operating system upgrades. And unfortunately, also, we just kind of realized this now over the last couple months. And so it's also too late kind of to do sort of fixes in old Postgres releases to fix this, right? Because they're already out there, you can't do that. So old releases is what people are mostly using now. The new ones are not, so Red Hat 8 is the first, let's say, major long-term with long-term support Linux distribution that does this. So this is now actually live. Debian is going to come out later this year. Ubuntu is already out, but this is not a long-term support release, so I guess not a lot of people will use this in production, hopefully. So we have started to gather some of this information on this wiki page. So maybe a lot of you have taken pictures now, or just bookmark that and check for advice. And when I say we, Postgres community, we're also working with our customers at Second Quadrant, obviously, on this. To an extent, these are not good answers, but we have to figure them out now, okay? So, last slide, so to speak. If you have questions about why does the sort behavior work the way you want, or this way, or you want it differently, or you disagree with how it should look, this is all defined in the Unicode collation algorithm. We've seen as options you can use to change behavior. We've seen libc has issues with locale stability, and we've complained to them many times over the years, and they basically said in friendly terms, it's like, we don't have the resources to deal with this, So this is not the best place to complain. So we did, for that reason, adopt ICU as an option, because they care about this more. Right now, ICU is only sort of on a per table level. My expectation and project for the next couple of years is to make this as an option the default for the global locale behavior. For the moment, if you do OS upgrades in the near future, please check, check if the glibc version has changed. Run reindex. There's also AM check, a contrib module in newer Postgres releases that you can check an index. But chances are, if your data contains, a space or a period or a hyphen, you're going to have a problem. So just do it, okay? And that's it. And we're at the end of time. So thank you very much. And let's have some drinks.
Thank you very much. If you have any questions, we can
Well, talk to me here if you're too embarrassed to ask.
Everyone wants to know about emojis, probably.
The who?
Everyone wants to know about emoji support, probably.
Yes, yes. Oh.
It was a joke. Okay.
Okay, let's go have the drinks. Question?
Small question. Is there any other mode to solve the accent insensitivity on older Postgres?
For accent insensitive, if you want to do that in older Postgres releases, you can use the unaccent contrib module, which just removes all the accents.
Okay.
So that's kind of the same as lower, basically. You just convert it to like the same form. So that's probably useful for that. That probably has similar special cases where there's not a one-to-one mapping in some cases, especially if you have sort of composed and decomposed characters and all that kind of wonderful extra stuff. But the unaccent is the one you want to look for. Yeah.
Thanks.
Anyone else?
This works only in 12.
The which one?
The collation specification for ICU. When you define it, that's only in Postgres 12 or it's usable before?
ICU is in Postgres 10.
Oh, so it works since 10.
Yeah, like this stuff, for example, works in 10. This is in 10. All this is in 10. The only thing that's new in Postgres 12 is this. Okay? So, again, there's a lot of sort of weird things in here, and this is kind of hard. Again, this is just basically, Postgres just passes this string through to ICU, and it does something with it. There's a lot of documentation out there, but it's very cryptic, so, you know, we can also, you know, if anyone has any sort of suggestions on how to improve the documentation in this space and stuff like that, that's also very welcome. It's all very complicated and cryptic right now, but the functionality is all there, so we can build on that. And or if you just want to write a blog post to explain, you know, what you did with it, that would also be welcome. So, please take a look.
Thank you, Peter.